Well, let's look at this example. Example 7, find the inverse function of, looks like a square root function. Same steps as before. I'm just going to replace f of x with a variable. Let's say that's just y. It's not too much. Don't worry too much about so now we have the same process. I need to solve for x. That's the whole point. Solve for x. So I go through exactly the same steps. So every term that doesn't have the x, I get rid of by adding or subtracting. So I subtract 3 from both sides. So the result is this. What do I do next? Well, I'm going to need to get rid of the square root functions. So at this point, you're really solving for this particular operation where inside of it is the variable I'm after. So because it's a square root function, I need to undo this. So for example, here I was adding, I need to subtract to undo the adding part. Now this whole thing's been square rooted, so I need to undo it. So I'm going to square both sides. And you notice I am showing steps here because I have a feeling that it might be been too long since we did some of these, and it's better to show a lot of more steps. Also, notice how closely I'm writing here. I'm sort of running, kind of worried about room, so I'm packing it in, but notice how much harder it is to watch each step when it's this close to each other. And notice how much cleaner this looks when I just introduce a little more white space. So crushing things in here is not a good idea. Look how busy and ugly this looks. So next up, I'm going to differentiate it, get a little bit further away, and notice how big of a difference this makes. So again, now I need to continue solving for x, but this is I could recognize a linear equation. So again, I have this term, doesn't have a variable in it. I need to get rid of this 2. Then I'm going to add 2 to both sides in order to do that. So here's a result, going to add to both sides, and I get the following. And the next thing I want to do is again get rid of this 3/2, and you notice it's the same step as before. I'm going to multiply it by the reciprocal, which is 2/3. So I'm going to multiply this entire side by 2/3. And I'm going to multiply this other side here also by 2/3. And again, I'm writing it out so you are clear what needs to happen. But notice how much freer this started to look like because I created some space. This becomes 1. And notice I'm going to just kind of do this dashy line. Why? Because I know this has 0 meaning. So I realize like if this is like a newspaper print, I'm going to the other side. And there it is. I'm going to just bring the x over here. X equals, and I'm going to distribute this across this term and this term. So 2/3. Notice I cannot distribute inside of this parentheses this one because I'm squaring. So I need to multiply this out before I can move to be able to distribute the 2/3 across. And the next part is 2/3 times 2. So I'm going to again show this. This is clear what I'm doing. And I'm going to clean this up now. I'm also going to replace x with its inverse. So notice it's inverse of y. That's now the new domain variable. And here I'm going to go 2 times 2 is 4. So 4/3. And there it is. That's the inverse function. And again, I can replace x with y with x. I'm not going to do this in this step. I personally don't even like this step. All right. So now I'm going to answer the next question. What is the domain of f of x? So now let's go back to f of x. We got this portion done, domain of f of x. Okay. So this now I have to look at this. Well, this entire equation. The 3 is not a problem. All I'm doing is adding 3 to some number. But this being inside the square root is a problem because, again, this radicand cannot be less than 0. It could be equal to 0, this whole thing, or greater than. So just like I've been doing with the roots, I just need to solve this inequality. I'm going to add x to 2 to both sides. Oh, adding 2 to both sides. Okay. And finally, I'm going to multiply both sides by the reciprocal. Again, it's a fraction. So every time I see a fraction, I'm not going to divide by 3/2. I'm going to multiply by the reciprocal, which is a positive number. So remember, if you multiply or divide by a positive number, the inequality doesn't change. If you multiply or divide by a negative number, you have to flip the inequality. So multiply here by the reciprocal, and I get, look, x must be greater than or equal to 2 to the 4/3. Okay. And that becomes the domain of f of x. That's the only issue with this part. So domain of f of x equals 4, sorry, not equals, not everything I'm just type, not the equal sign, just it is. And then I start at negative 4/3 and then go to infinity. So that's the domain of this function. Now, what's the range? Now, here is where I'm going to use all the tools that we have used so far. We have used now transformations. So now let's look at this. The range of f of x is the domain of this function. So let's kind of take a look at this really quick. What's happening here? Well, I also could look at transformations, but I'm looking from this one. This is a quadratic. And what's happening to this quadratic? Well, again, the parent function is just this simple y equals x squared, or the basic function. This one is, again, has a vertex at 0, 0. And now, if I look closely, I start seeing that there's been a linear transformation taking place. I have subtracted 3. So that means there's a shift, horizontal shift by 3. And that's to the right. So now this point has moved all the way here to the right. Okay. And what else is happening? Well, it's been moved up 4/3 and stretched by 2/3. But the question becomes, do I need to kind of worry about that? Because all I care it is about right now, the domain of this, the input. If I add 4/3, that's affecting the the vertical. If I multiply by 2/3 after everything's being squared, again, it's after the original function does this thing. So the only thing that's happened as far as the x is concerned is I've moved it all the way over there. Okay. So now the question becomes, what is the domain of this function that we've found? Well, right now it seems to just, oh, it's everything. But it can't be everything because this function is definitely not one-to-one. Now we're getting into a little quandary. How can we make this whole thing work? Well, it turns out there's kind of a simple answer to this. We are not going to deal with the entire quadratic. We're only dealing with a part of the quadratic. So now it's starting a little bit tricky to diagnose what's happening. So let me go back to the original. The question is, what is the range of f of x? So now I start thinking, wait a minute, could I apply transformation to this original function to get the answer? And then I think we can. It might be easier to do a direct attack than this. So when I look at this, what is the parent function? So the parent function is just y equals square root of x. And that's what this graph looks like. So what's happened inside? Well, it looks like it has been compressed and shifted horizontally. So this, as far as horizontal, there's been some kind of compression and movement. Okay? But remember, we're after the range. What is the range of f of x? So that doesn't affect the range. So even if this gets moved somewhere, let's say just here, I'm not even worried about it, and even compress or stretch, it's not changing the range. The range is, again, looking at this vertical. The only thing that's going to change the range is adding this 3. So the parent function has a range of starting at 0 to infinity. Again, that's the range where we're going again. This is the vertical is the range. You can see that is the range, 0 to infinity. What has happened to this range now? Well, it looks like I've added 3 to it. So what's the range then of this original function? It looks like I'm adding 3, so I'm going to add 3 to this. So range of f of x is 3 to infinity. Because all I've done is taken the parent function and shifted it up 3 units. Okay. All right, that's fantastic. Now, we didn't ask this question, but I think it's an important one. So what is the domain of f inverse of x? Again, notice we're so used to putting x in there, but I haven't changed it for this question. So I'm going to use y. So now the domain, well, and really, here's the reason why I don't want to change it, because it starts to make clear that all we're doing is swapping naming, or what's in and what's out. The range is f of x equals, sorry, the function is f of x equals y. The range applies to the y's. And notice what I now want to find the domain of f inverse. Of course, we're talking about the y's now. So what is the domain of f inverse? Well, it's the range of this one. So the domain is just going to be that. So reality, what does this function look like? The inverse function that we just found. Is it this picture right here? No. The picture is not the full parabola. It looks like I start at 3 at the vertex and shift, and that's it. It's half a parabola. That is what the inverse function is. And that makes sense because I need it to be 1-to-1. If I only look at half of the parabola, all of a sudden I have a 1-to-1 function. So this is what we say is restricting domain. So that we have an inverse function.